While the Minuteman program has been continually improved to increase range, accuracy, and reliability, the Air Force is concerned about improving the survivability of the land-based ICBM force. To fulfill future ICBM requirements, the Air Force has initiated the MX program. Two major tasks are underway: the study and selection of mobile basing options and the definition of a new and larger ICBM. Two mobile basing options have been selected for more detailed evaluation: the shelter system and the trench system. The trench concept includes a network of underground trenches that would provide no specific aim point data for enemy missiles. The trench would be strong enough to resist blast pressures, yet still allow breakout for missile launches from unmanned vehicles. The shelter concept involves a random switching of missiles between hardened shelters on mobile transport systems. It would force an enemy to execute a complex and difficult attack to destroy each sheltered missile. The missile design itself would result in larger payloads, improved efficiency, and increased accuracy over the Minuteman III. Current hardware validation is in progress to reduce technological risks.
The system will house warheads of the same or better quality than the re-entry vehicle previously developed for Minuteman III. The first flight test of the MX missile is scheduled for 1983 from Vandenberg Air Force Base, California, with the first 10 missiles operational in mid-1986. The MX basing mode is a multiple protective shelter system. The planned cluster deployment areas are located in the southwestern United States. This photograph of a typical valley has been retouched to simulate the locations of shelters and roads. The following animation of the basing mode is not drawn to scale, and the shelters and roads have been intentionally enlarged to clearly depict the operation of the system. A cluster road will connect 23 horizontal shelters which support a single MX missile. A specially designed transporter will move the missile in its launcher on unpaved roads between shelters. A 2.5-acre area around each shelter, roughly the same size as currently surrounding each Minuteman silo, will be fenced for security reasons. All other areas will continue to be open to the public. The MX system is currently planned for 200 missiles and 4,600 shelters. The MX shelters and support areas will require about 25 square nautical miles of land to be removed from public use. Other activities, such as mining and ranching, will be permitted in the areas between the shelters. Private aircraft will be permitted to fly over them in accordance with FAA flight rules. Each of the valleys that appears usable based on geological considerations will accommodate several clusters. Adjacent complexes will be interconnected by service roads unable to support the weight of the transporter. Thus, a single MX missile will be constantly associated with a cluster of 23 protective shelters. Several factors contribute to the survivability of the system. Each shelter will be about a mile from any other, so that one enemy warhead could not eliminate more than one shelter. The transporter vehicle carrying the missile and launcher would periodically move on unpaved roads from shelter to shelter. At one of the 23 shelters, the missile and its launcher would be installed. A mass simulator with identical weight and other properties would then replace the missile and launcher in the transporter. These simulators would have been installed in each shelter at the time of construction. At each remaining shelter, installation procedures using the mass simulators would be carried out, so that Soviet surveillance systems would not know which shelter actually contains the missile. Additionally, electromagnetic and other emissions would be simulated in each empty shelter and in the transporter. Normally, the MX missile would change shelters within its cluster only after a routine maintenance cycle, perhaps a few times per year. If compromise of missile location is suspected, the system could operate in two additional ways to maintain its survivability. First, all missiles could be relocated to other shelters in several hours. Such a reposturing would ensure that all missile locations remain undetected. Secondly, the transporter with its missile and launcher could be placed in constant motion. Upon tactical warning of attack, the missile and launcher would be deployed into the nearest shelter. Through a combination of concealment and mobility, the security of the MX system can be maintained. As a result, the Soviets must target all 4,600 shelters to destroy a significant number of MX missiles, which in itself should deter such an attack. Should the National Command authorities require MX to retaliate, the shelter door would open, the launcher would emerge, erect, and eject the missile. The first stage would ignite, and MX would be on its way to its assigned targets. Many tests have been conducted in the evaluation of the various basing mode concepts. This 1.4 million pound transporter vehicle is now being used for roadability and maneuverability testing. Several different types of dirt and gravel roads have been constructed for the vehicle to operate on to determine cost and durability. Scale models of horizontal shelters were constructed and subjected to high explosive blasts, simulating nuclear environments to gather design data. Large sheltered doors were constructed and tested in debris studies. This data is being applied to the current design. Missile ejection from a canister has been repeatedly demonstrated in a series of design feasibility tests, and the concept of free flight ignition, or cold launch, has been demonstrated in the Polaris, Poseidon, Trident flight tests. The MX system has been conceived to maximize SALT verification. The design enables Soviet surveillance systems to determine how many missile launchers have been assembled and deployed. First, at the designated assembly area, all missile and launcher components would be received from their manufacturers. Assembly would occur in facilities with openable roofs to expedite observation for SALT verification. Only one missile would be assembled at a time, with the process taking about a week. The assembled missile in its launcher would be transferred to the deployment area using a special transport vehicle on a designated transportation network. Each shelter cluster would be accessible only through a major verification barrier. The special transport vehicle would deposit the missile in its launcher at the cluster maintenance facility. After the special transport vehicle leaves, the barrier would be reinstalled, ensuring that a second missile could not be introduced into that cluster. The missile in its launcher would be loaded into the transporter in the cluster, the only place this unit will exist in operational form. This combined unit would now visit each of the 23 shelters, with the missile and launcher being installed inside one of them and its place in the transporter taken by the simulator. This entire assembly process would be repeated for each shelter cluster and would be reversed should removal of any missile be required. Emplacement of an MX missile and launcher for each set of shelters would complete deployment for that valley. As another verification feature, each shelter would be fitted with ports, which could be removed for inspection. This would allow Soviet surveillance systems to verify the number of deployed missiles. The transporter itself is another aid to SALT verification. Just slightly smaller than this earlier version, at a loaded weight of up to 1.25 million pounds and a length of 180 feet, the transporter will be too heavy and too cumbersome to travel off-road or on other than the specially constructed roads. It would sink into the surface, be trapped by terrain variations, or tip over. Every effort will be made to minimize the environmental impact of the MX. In addition to withdrawing as little public land as possible, the shelters and road networks are being designed to be nearly flush with the ground for maximum landscape blending. It should be remembered that a typical valley with shelters and roads drawn in to actual scale would look like this photo rather than as depicted for clarity in the animation. The required environmental impact studies are underway. 2 have been completed and 2 more are in process, one for selection of a deployment area and the other for a production decision in 1983. There may also be supplemental environmental impact statements. MX will be as energy self-sufficient as possible. Each shelter may require approximately 20 kilowatts of power. To generate the power required, the use of solar or other renewable energy systems, such as geothermal plants and windmills, will be investigated to reduce the need for commercial power. The overall cost of the MX system during its 10-year acquisition period is about $33 billion in 1980 constant dollars. Its operating costs are $440 million per year in 1980 dollars. As a comparison, our Minuteman system cost $40 billion in comparable dollars, and its operation averages about $340 million in 1980 dollars. Our B-52 program cost $54 billion in 1980 dollars, and Trident will cost $39 billion. Since both are manned systems and more labor-intensive, the operating cost of these systems runs about 3 times the cost of MX. MX has been sized within the constraints of SALT II and to a level necessary to maintain the deterrent posture of our strategic triad. With SLBM forces at near parity and the U.S. bomber forces with an advantage in cruise missiles, it is important that the MX role be one of assuring a balance with the Soviet ICBM forces. The MX operational force, as currently planned, presents any adversary with a choice of unacceptable options. If the Soviets choose to attack our triad, excluding the 4,600 MX shelters, they can expect an unacceptable response from 200 MX missiles with 2,000 warheads. Or if they choose to attack the entire triad, including MX, they would expend almost all of their ICBM resources, leaving the U.S. with almost half of the MX warheads. In either case, any aggressor is deterred from an initial attack if the outcome is guaranteed to place him at a disadvantage. In addition to preserving our deterrent posture without adding more ICBMs to our inventory, MX will provide a new strategic capability to keep pace with possible Soviet force buildups by adding additional shelters instead of missiles. Moreover, the MX system provides the flexibility to deter a high Soviet warhead buildup. We could counter such a Soviet buildup by increasing our shelters encased with their warheads, or, in the extreme case, by adding a ballistic missile defense to MX if the Soviet actions warranted withdrawal from the existing anti-ballistic missile treaty. In this regard, we plan to construct the basic 4,600 shelters in such a way that an additional 2,000 shelters could be added within the original shelter deployment area. Furthermore, the Air Force and Army are working together to ensure that MX is designed to be compatible with the Army's low-altitude ballistic missile defense system. DoD planners believe such a Soviet force expansion against our shelters would not be attractive to the Soviet Union. In fact, the Department of Defense believes that the MX will provide the foundation to ultimately reduce the number of strategic arms in future arms control agreements. By decoupling force survivability from force size, we have the flexibility to adjust the number of shelters in the face of an expanding threat without increasing the number of missiles. Conversely, we could remove some number of missiles as part of a future arms control agreement while maintaining a constant number of shelters. This is a unique and extremely desirable feature of the MX basing mode. It provides a powerful incentive to the Soviets to seek stability rather than additional firepower. In summary, MX is vitally necessary to the future security of the United States. It sustains our strategic triad and, most importantly, sets the climate for mutual nuclear arms reductions for future arms control agreements. MX ensures our ICBM survivability into the 21st century.